hopefully, if we have something that we need to, if it lags, maybe tomorrow. But my plan is at most to take it until tomorrow. So I'm going to try to cover a lot of basics as much as possible today, so that tomorrow we can start building. Because I think it would be nice if we start building on Solana early enough.
Yes.
And yeah, so I'm
Uh,
going to try to share my screen.
I'm
You
also
let me know.
I'm also
Yes.
going live on YouTube right now. So
Oh,
I think it's a very good time to start officially.
all right. So let me try to share my screen. You let me know if you see what you're seeing. And yes, so let me try to clear my desktop. And yeah, so I don't know if you guys see my screen.
Yes.
Are we good on YouTube?
Um.
Okay. Before I kickstart, like I said, we are one of the few people that are building Web3 products in Africa. And like I said, we are building one ramp which is an aggregator of sorts. An aggregator, I mean, it allows applications to integrate Web3 using mobile money. Maybe you have your users, and maybe you're building some sort of Web3 application, and you want your users to get into the Web3 space. You can use the OneRAMP API. So if you go to docs.oneramp, we have very nice documentation that takes you through everything that you need to use when you're integrating. And yes, so we have the SDK, and recently we have been working on the Fiat Connect specification, which is a specification made by Celo. And yeah, Valora, Celo, MiniPay, and all that community uses the specifications. So we try to integrate that. And yes, it's live right now. So if you have any integration, you can use Fiat Connect. And also you're working on the API, which is less more of Fiat Connect, because Fiat Connect is tied onto Celo. So you're trying to have another API that works on other currencies and beyond CSD. We also have this widget, which is an end-to-end user, like where users can connect their accounts, they buy some Bitcoin. Currently, we have SATs, and then we have Celo Dollar, currently serving in Uganda and Kenya. It straight up works to your mobile money. And the newest feature we've launched today is the sale. So currently now you can sell your USD or your SATs, and then you get your money on your mobile money. Another product that we're working on is Shukuru, which is a mobile application that is also using the OneRamp APIs. And basically, this is just an application that users can download and have a wallet on their phone. It has Lightning Network, Bitcoin Lightning Network, and also has Celo Dollar. So it is a Lightning wallet with basically all the functionality that you need in one place. So we're also working on adding the sale. We're also working on adding the deposit. So hopefully, sometime within this week, we'll also launch that. Yes. So enough of that. I'll drop. I think Yanni will drop the links to these websites if you guys are interested to check them out.
Okay.
But if we dive in, we are going to build on Solana. I do not have a lot of text. I didn't type a lot, but I'm going to try to talk my way through it as much as possible so that I can help you guys dive a bit home. So Solana, if you go to solana.com, this is their website. Most of these websites have very nice interface. I don't know why Web3 applications need to be dark, but yes, I think it's the convention. So this is the Solana. Most of them are very dark like this. And when you look at their tagline, it's powerful for developers and it's fast for everyone. And this is something that I can testify. There is no lie in these two statements. It's a powerful blockchain. It's very powerful. It has a very, very nice tooling, and its possibilities are endless. It's like I've seen people comparing it with Visa. The transaction times are close to instant. So, and the other thing is that it's very cheap. If you look at the transaction, the amount of fees that you pay per transaction on Solana, you realize that it's very, very, very cheap. It's incredibly cheap, to the point that I've seen people adding it in streaming applications, whereby maybe you're using someone is building a game application and they're streaming money. Yes, so imagine streaming real money as payments. Yes, so that shows you how fast the Solana blockchain is and how, like, the speed at which it's growing. It's incredible, and it's something. So you could see the partnerships. It's working with Shopify. They have Solana Pay. It's called Solana SDK. That is very, very, very nice to integrate in your applications. And I think it's something that maybe OneRamp will have to have at some point in future, because it's a very, very nice framework. So it's what we are going to try to build today. And when you go to this website, everything that I'm going to be talking about is going to be coming from this website. So if I miss something, or if I jump something, you can go ahead and look through the document. It's a very, very nice documentation if you go through it. So I have a few notes that I'm going to try to go through. I've done writing using pen. I didn't type. So if you hear papers struggling in the background, don't get scared. Just know it's me. So, okay, let's go ahead and look at the overview. What is Solana? So Solana is another blockchain as the other blockchains, but every blockchain is different. Every blockchain has a solution. Every blockchain has what it's trying to solve, and and also it has some sort of mechanism that it uses for it to achieve what it's trying to solve. And when you look at Solana, Solana is a proof of stake, and I'm saying that in quotes. It's a proof of stake blockchain, but it's a proof of stake with some extra functionalities added to it. So what are those extra functionalities? So most of the blockchains that we know, when you come back from Bitcoin is proof of work, and Ethereum is proof of stake. Solana is proof of stake with something extra, and that something extra added on top of it is proof of history. So I'm not going to go so much into the mathematics and the functionality of proof of history, but what you need to know is the way proof of history works is validators keep track of blocks. So for example, when a block is created on the Solana blockchain, it is given a certain timestamp. So with that timestamp, when the block is submitted, validators will organize every block that comes according to the timestamp that it has. So most of the blockchains, the reason why some of the blockchains are slow is because all these blocks are supposed to be organized in a way. So if you look at the proof of stake, a lot of validators will have their nodes, and each node will have to keep track of the time. So when a block is created and it has a certain timestamp, every validator will ask each other validator what the timestamp is. So they keep on asking each other, what time is it? What time is it? What time is it? And they will have to match the times on each block. And when they are submitting it, they will have to align them according to the timestamp. So the fact that you have to listen to other nodes for the timestamp makes some of the blockchains a little bit slow, because it's communication. You need to understand what time is, and computers and all of that. But what Solana does, it says, hey, you know what? We are not going to keep on asking what timestamp. But what you have to do is just keep on throwing blocks at us. So the more they keep on every transaction that is mined, every block that is created is thrown to the validators. And what the validators do is they keep track on the timestamp at which the block has been created, and they organize them for you like they organize it even when you've already thrown the block onto the chain. So that is why it's very fast, because you do not have to wait for the validation on the timestamp and every that. It's just organized, and it's the reason why it's very fast. So it's something that is really nice. If you want to go through that, I'm going to throw some links for you so that you can go and look at how proof of history works for Solana. I think it's very, very nice technology that they are going. So that is the overview of what Solana does. We are going to come back on Solana because I do not want to spend a lot of time on Solana. But as you know, when you're trying to learn something, you need to come from the basics. You need to understand what the basics are, so that when you get to the real parts, it's very easy for you to glue the things together because you've got your basics right. So basically, that is Solana. We are going to come back on its implementations and the difference between Solana programs and Ethereum programs and whatnot. And yeah, it's something that we'll address. But I want to just dive into Rust right now, because what Solana is built on top of Rust. Rust is one of those programming languages that is really loved recently, and I think it's the language that a lot of developers are going to start writing in a few years from now, because it's being picked up by a lot of industries, not even just for the blockchain, but even for other fields. And I think it's a very good investment if you can take your time and learn Rust right now, because I think you will benefit in the long run. So I'm going to try to take you through a few of Rust functionalities. But maybe if you are a little bit curious, you can go and search and look and see the blockchains that are powered with Rust. So I'll go and write Rust powered blockchains, and you could see that there are very many actually chains that are powered by Rust, ranging from Polkadot, ranging from Solana, from Nia. We have these, we have Hyperledger, we have all of these. So it is something that I don't think you will regret in the long run. And more of them are still popping out. I think we've seen Sui. I don't know if I am saying it right, but I think it also has some blockchain, has some Rust somewhere. So I think it's something that you can benefit to take through. So the best way to learn Rust is to go through the Rust book. They call it the book. I do not know why they call it the book. So, but yeah, when you search Rust, it will take you to this Rust book. It has a very, 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 very good documentation. If you guys have ever worked with Django and you think the Django documentation is very good, you haven't tried the Rust book. It's a very, very good book. And yes, you can go deeper, but we are going to only cover what you need to know so that we can get started, because you don't need to have a lot of stuff. You don't need to have a lot of low-level Rust for you to start building Solana programs. It's the beauty of that. So I'm going to try to show you a few tools that you may need to keep this very simple. I'm going to try programs and libraries and things kind of that. So, but maybe if you are trying to go and install it locally, you can go to Solana. I think it's Solana Anchor install, and it gives you this Anchor documentation and to show you all the steps that you need to install Solana locally. You first have to install Rust, and then after installing Rust, you go and install Anchor framework, and then you start writing your Solana programs locally. That is if you really want to do it locally. But to keep this very simple, we are not going to install Rust locally. I'm going to show you a few resources. So if you go to the Rust playground, so when you go to Rust playground, you have this very nice playground where you can, I think it gives you some sort of editor. Let me try to change this to light. Twilight is the way. Yes, so this is what you may use. So if I zoom that there, so you go to play.rust-lang.org, and it will show you this Rust playground where you can write a Rust code without installing anything. But I'm not going to use this. I'm going to code locally because I do not want to keep on moving around the tabs. So for me, I'm going to use my VS Code because I've already installed Rust locally. So let me try to create my small repo here and open VS Code. So if you really have any questions, don't hesitate. You can interrupt. And let me try to make this a little bit dark, a little bit lighter. Let me, hopefully I still remember what the color here. I think it's this. So for you do not need to worry about this because you are going to be doing your coding in the browser. So let me create a new Rust project and okay. So hopefully, okay. So if you're with me and you're doing it in your browser, I think this is something similar that you have. And I think we can just kickstart right away with the basics. So everything that you really need to understand, most of the time when you're learning a new language, or maybe when you're trying to build something new, the first thing that you need to address is what is you to learn is the data types. So let me try to see why is my Rust analyzer not working. Okay. Also this. Maybe open it again. So yeah. So what Rust is a language that is I don't know how to say it in the right way, but I try to think of it as a language that is like it is interpreted on, like it's validated as you code. Like every mistake that you make, every single line of code that you write is interpreted by the compiler before even you compile it. Like you know your mistakes right before even you compile it. So that's why it's very loved because it lets you catch errors before you even compile your language. So that's why it's a very loved language, because it makes it almost very difficult to make a mistake. It forces you to write code the right way, the safe way, as the right people try to say it. So when you go to your background, I think this is your first line. So when you press run, and it will be your first line of code will be print hello world. So mine, I think mine I can run it here, and when I run that there, you can see mine is hello world. Beautiful. So that's your first line of Rust code. So like any other language, it has a few data types that you need to take note of. For example, we have We have a few data types that you need to take up. They have integers. So they have integers, they have floats, they have booleans, they have strings, and all of that. So if you're trying to, the way you can declare a variable, most of the variables in Rust, they use let, which is the most common way to do it. So for example, maybe I have the variable x, and I want to set it to 5. So what happens is Rust is a statically typed language. You need to invert the type. So you can see this is an I32. There are various types. We have I32, we have, I believe, I16, we have I64. So these are all data types that you need to think about. What I does is, I believe it's signed integer, whereby it only allows you to declare variables that will not go into negatives. For example, if I say y is equal to I32 negative 5. So it So it gives you a certain range of values that you need to declare, because what these types are is they show you the memory size on the compiler. So maybe if I go back to the Rust book and I show you what these data types are here, you can see. So the length here is 8-bit. I6 is 16-bit, I3 is 64-bit, is 32, and I64 is 64-bit. So most of the time you may not need to infer it you may not need to infer it like that. Sometimes it's written by it's added by the compiler in the background, but you may find sometimes some code where it's added. You need to add. So we talked about the floats. So if I have maybe variable 2.5, then that is an F64. So you can still do a few arithmetic functions on these variables. For example, I can add x plus y. So maybe I say sum of x plus y. And the way you can print and see the answer, there's the I think in it. So it goes with the double quotes, those curly braces, and maybe the variable here. So that's the syntax. So if I go ahead and press run, you can see it's a 0. Maybe let me change this to a better number, and maybe I press run. You can see it's 15. So I think there are rules that you need to follow when you're doing something like this. For example, let me put this up here. So we know that Z is a float. So one thing it will not allow you to do is to do a calculation on types that are not the same. So let me say I'm trying to get the sum of x, which is an I32, minus a float, which is 2.5. Sorry, which is z, right? So you can see the compiler is already complaining, like, hey, you cannot subtract a float from an integer. And this is one thing that I really love with Rust, is it gives you a very, very descriptive error message. Like, this is pure English. Cannot subtract float from integer. Like, even a young kid can understand what it's trying to tell you. So all these types, like, they have to be the same data types. So maybe the way you can go ahead with it, in Python I've seen people doing. I think in Python they do something like this. I'm not mistaken. Maybe do something like that, and then you transform Z into an integer, and it works. So Rust has something similar. And for that, maybe let's try to transform X into a float. So we have the as. So you go and write F as F64. And the moment you change that, you can see that you can go ahead and still print the sum, and let me say sum, go and write sum and run the code. You can see that this has worked. So the moment you check X as an F64, and that means it's going to match with Z, and the moment that it will always infer the variable of Z, because you've already changed X into a float. So another data type that we are going to go ahead to look at is the Boolean. Boolean is something that most of us really know. Is true, is not true. So for example, if I have a Boolean that says let install, and I change and I say maybe install is true. If you know install guys, so you can see that it's true. And then maybe I may want to change install. So install is false. So immediately, this is what I was talking about. Immediately you make a mistake in Rust, it's going to tell you. It's going to tell you immediately. And the good thing that you can do, the best way you can do it, you can learn Rust, is to try to read the error messages. So if I hover here, it tells me cannot mutate install. So what you need to understand is that every variable declared in Rust is immutable, it's unchangeable. It's going to stay static until it goes out of scope. So it will stay. It will be unchangeable. That's what you need to know. If you try to write code in JavaScript, it has something like this. For example, y is 24. It works in a similar way as Rust. And yes, so you need to. So here it's the same thing. So the way you can go around this, and maybe you want to change this, is to declare this variable mute. And the moment you add this mute keyword, then it will allow you to change that to false. So yeah, the moment you want to the variable, you need to change it to add this mute keyword, and then it will allow you to always change the data inside of it. Another thing that I would like to cover on very fast is the chars. So the way Rust does it, when you compare with the normal languages, is it treats strings and chars differently. So let me show you what I'm trying to talk about. So when you say I have a char, maybe my char, my variable char, and I have a letter A, for example. So this is a char. You can see it's already inferred as a char. So it's very strict in the fact that the moment I change this to a double, it changes the data type. You see, it's no longer a char. So we'll see what that means. So a single letter, a single character is a char. So and it must be annotated with these single quotes, or else it will change the data type. So maybe let me try to change the char. Maybe my char is being, and let me see that. So yeah, so that is that, and then we'll see why. Actually, we don't need that. So we'll see why we can do some of this with char as we go ahead. So, and then when we come to, I want to cover strings. There's another data type called strings. So what a string does, I've shown you recently. So we have this str, and then if I have a name Bob, and then you can see this is str, which is the string character in in Rust. So the way it does that. So let me try to to show you. Another thing is that this string also, this str string is also immutable by default. For example, if I try to change, let me change this first name. Relatable. So if I come ahead and try to change first name to Peter, and then I have to change this to mute. So I can always change, the moment I add this, I can always change the name to the variable that I always wanted. So the mute keyword is very, very important. And also, I can still log using the printer macro. So maybe first name, and if I run that, you can see name Peter. So these are the simple stuff, the usual stuff. But most of the stuff that you've been using in written coding before. So the keyword is try to do arithmetic operations on stuff with different data types. Sometimes most of the time you'll have to change so that they match. So all the data types have to match. If you're trying to do it on I32, on Y, X must also be an I32, or else you will have to change it. So every variable that is bound to change is supposed to have this mute keyword. Yeah. So when we move on, I'll try to cover what arrays are. So arrays in Rust are not very different from other programming languages, but they have a few stuff that you need to think about. So for example, if I have an array of let's say I'll have an array of hero names. So maybe an array of hero names, and my superheroes, I'll have maybe Bruce, maybe I have Diana, and maybe I have Clark. So those are my heroes. So you see, this Rust compiler is really nice. So it really infers the data type. So we have this str. So it's telling you that this hero name is a string, is an array of 3 objects. So I think it's instances. It's an array of 3 strings, which is 0, 1, I think 1, 2, 3. Sorry. So it counts them like 2 of the length of 3, and it has to be that. So I can still log. Oh, maybe if I log. So maybe let's go back to this. So it shows you that this array is of strings. If I try to add maybe another data type, maybe I'm going to add Bruce's age, maybe it's 42. So you see, it's complaining. It complains right away, and it tells you we have mismatch types. So it's expecting the string to be of, it's expecting the array to be of strings, but then it got a number. So it's strongly not of you to add types that are not matching. So all of this has to be of strings. So you need to keep that. So if you want to log, so let me write heroes, and I'll go ahead and write hero names. I think this will be better than hero names. And then, so another thing that is you need to understand is the print macro. This is called the print macro. So the print macro, sometimes you will have to unpack the variables. So recently we were logging just a single string. Here is the first name, this is just Peter, this is B, this is True, this is Sam, it's just a single number. But then this is a full list. This print macro does not know how to handle that. It cannot just print it there. So sometimes you will have to tell it to unpack it. So the way you can tell it to unpack it is to have this semicolon here, and the moment you add this semicolon inside here, it these heroes and to them there. So and then let's play. I think I'm going to start this play button is running away from me. So you can see here it has unpacked the list and it has pointed that out. So let me try to get rid of this of that. So this is an array with the same data types. So let me say data types. The Python people call it a list. So yeah, so we can also have an array of maybe numbers. So let me say these heroes have age. So I'm going to write age. And the Bruce is 42, Diana is 34, and then Clark is 55. So you can see it basically in, and it knows that this is an array of I32 of length 3. Cool. So and also another thing that you may find yourself doing is commonly is you may want to index a few information in this. So for example, maybe let me add a few letters, numbers here, and I want to slice it. I want to slice some few numbers. So I'll have, let me add a new variable, and I'll say first pages, and the way you have to slice, I'll call those heroes pages. So the way you can slice in Rust is you add this, and then so I'll explain what this means, but just ignore it. Just think about that you need to have it there. So you get the variable with the list, and put these curly braces and identify where you want to start from. So if I want to get from 40 to 55, I'll tell compiler, start from the very, very, very beginning, like that. And then the next variable that you add here is where you want it to end. So here I'm going to count from 0, 1, 2, and I can put 2 there. So I'm telling it to start from the beginning and go up to 2. Remember, it will start from 0 and then we count from 0. So let me try to print that, and I'll say pages. Don't forget to unpack that. Then I'll say as pages. And then I'll go and write the entire list. I'll go ahead and try cargo run. Oh, I have to go there. So I'll go ahead and write cargo run. And you can see, so it started from 42, which is the very, very beginning. So it counted 0, 1, and then it doesn't include this. So if you want it to include 2, then you add that equal sign. So the moment you add that equal sign, and then it will also include 2. So yeah, you can also tell it maybe to start from somewhere. Maybe I want it to start from 1. So it will jump 0, and then it will start from 1. So let's see what it tells us. So it jumps 0, and then it starts from 1, and then it writes 2, and then it skips this. So if I wanted to add the third one, I add that equal sign, and then boom, also adds it there. So these are the basic stuff that you may find yourself doing when you're playing around with Solana programs. And yes, so these are the few stuff that you may find yourself doing. And if you want to keep on playing around with data types, you may just go ahead and play around with the documentation. It's very nice. We have this difference, we have this application, we have the reminder, we have the divide. Then it gives you some few stuff like the characters, what you can play around with the characters, and all of this stuff. So maybe if you want to expand on that, then you can go ahead and look at that. So, unless, oh my god, time is flying. We have 10 minutes. Oh, okay. So, another thing, I don't know if you guys have any questions so far.
Okay. Yeah, personally, I think we shall extend a bit, at least until the topic is done. We can go to 1.5 hours so that, when you're reading these tutorials, you can have it from a beginning to a finish. So, yes.
Okay.
All right.
Okay, I'll try to.
All is well. All is well. The pace is good.
Expand as much as possible so that I can cover most, but yeah, what's the. Okay, so I think I should push this repo. Okay, I'm going to share with you guys this repo so that you can play around with this. So maybe I want to mess it up a little bit. So okay, let me try to. I want to cover functions. So another data type that you're going to use a lot in the Solana program is functions. Functions. This is something that you're going to cover a lot. So I'm going to try to create a new module. And okay, so we have this, and maybe. So for the guys that are doing it in the, you may not need to do this. I'm trying to organize up this repo so that maybe if you guys want to play around with it, you can know where to start from. So let me put this in a separate module, and maybe let me put it in a phone called basics. Hopefully I get it right. Put it up, and okay, okay, so basics is there. So we are going to cover functions. So let me also include the functions here so that my compiler can know where to find it and get my link right. Okay, beautiful. So this is the functions. So functions in Rust are not very different, and they are not very difficult to understand syntax-wise. So they are very straightforward. So they go with the fn keyword. So use the fn keyword and the function name. Maybe I'll write my first function. So my first. So if you notice, I'm using this. I think it's called snake case. So the convention to use a snake case. I know languages like JavaScript, you're supposed to write something like this. Technically, you can do it in Rust, but it's not very, very common. Usually, you'll find people using snake case like that. So, yeah. So that is how you declare a function in Rust. So this is a function that maybe it does something. Maybe I wanted to print something. Maybe I wanted to print hello world. So I'll write my function hello world. Beautiful. And so the way you can call this function, I want to call this function from main. So I'll make it publicly available. So for you guys, if you're doing it in a browser, you may just call the function like this. Hello? Okay, my linter is not coming because it's not called. But if you're doing it in the browser, you can just call your function like this, and yeah, everything can work. But now, For me, I'll have to import it in my main function so that I can. Oh, let me change this. Let me change this. I may have issues with my. With the built-in function because I had named it function in which Rust has a static type that is called functions. I may have issues, so I've just changed that and I'm going to call it. So the way you can call it is use this. So for me, I'm importing it from this module and I'm calling it the usual way. So if I go ahead and open my terminal and I say cargo run, and you can see I get this hello world. So what this function is doing is the bare minimum, it's just printing hello world. So what if I want it, maybe let me create a new one. Maybe I want to create a function that maybe greet someone. Maybe I'll so you write fn and I say greet function. Maybe it greets someone like, hey, good morning, Charlie. Good morning, Peter. So the first thing it will take is arguments. So maybe argument is a name. So like remember we said in Rust you need to declare the types. So we know that name is going to be a string. And so we'll say print line and we'll say good morning and then we'll add name. So okay. Oh. So I had done that issue there. So the way you can call that, the name maybe I'll say Jovan, the toString, and then so if I say cargo run, and then you can see that is what it's telling me. We have this data type. I don't know if you guys saw it. What this data type, we'll cover it in a few. We'll cover it later how it works because it's different. It's a little bit different from str in the way it does its stuff. So yeah, but usually it's what the most used. It's what a lot of people use. So yeah. So maybe we have a function that gets a full name. Maybe I want to get the full name of the user. I'll try to play around with a function that takes in maybe more than one argument. So I'll write it. I'll call it get full name. I have the first name. So the first name takes in a string. The last name takes in a string. And that. And now this time I want this function to maybe return the full name. Like I want it to take in the first name, the last name, and then it returns the full name combined. It's what I want to achieve here. So any function that is returning any type of data, you need to tell Rust that this function is going to declare that data. So I want this function to return a string of full name combined. So I need to tell Rust that, hey, this function here is going to return a string. So the moment you add that, it will know that this function is going to return a string. If I don't do that and I try to return a string, it will complain. So so the way you get the full name, let me try to put it in a variable, maybe full name. So one thing that you cannot do is this. You get, you can't do that. you can't do that in Rust. So you will have to format it as a string so that you can combine them and concatenate them in the way you want. So hopefully, luckily there's a macro in Rust that you can use to add strings. So it's the format, and the way it works, it's very, very similar to the print line. And so we have the first name, and then we have the last name. So I like adding here variables and numbers to show me which is which. So this is the first, this is the last, and I can have return full name. So when I call this function, try to comment that out. So when I call, maybe I have variables, and I'll say first name, variables of the first name, and I have rows, and I have variables of the last name. I have Bruce Wayne. I have to transform that to a big string. So I have variables of first and last name, and when I call them, I add them there to the function, and so I know that it's going to return the full name, and maybe I'll say the full name is Batman. So the full name is Batman. So and then this is first name. Sorry, maybe this is last name. So the full name the full name is Batman. So it goes in here. It enters this function. It concocts them by this format function and returns that, and then that variable is cached, like it's returned as Batman. And when I print that, I'll say Batman name is that, and I'll say Batman. So if I call that, it shows that Batman name is Bruce Wayne. So there's another way you can do it. You may not need to use the return keyword. You can remove this return keyword. And the moment you have that return keyword, I don't know if you've noticed that in Rust you must have this calibrate, like the semicolon, sorry. You must have them.
Mr. Jova, we seem known to your screen as I think we can wait for him to get back, and we conclude. Mr. Jovan, I think you are off. Let me. Okay, we are here waiting for you, Mr. Jovan. I think I don't know whether it was a technical glitch or internet connection, but yes, we are still waiting for you to continue.
Yes. Sorry about that. I think my internet went off. I do not know how long that was. I may have been talking for 30 minutes alone.
No, there are very few minutes. Trust
So,
me.
oh, okay, okay. Okay, let me try to go through. Let me try to share my screen very fast so guys can get it. So, you tell me if you see it.
Yes.
You see my screen, guys?
Yes, I see it perfectly.
Yes, so the functions, like I said, maybe to take you back a little bit before I went off, I was showing you this get full name where it takes in two strings, and when it takes in two strings, it must want it to return something. If you want it to spit out something, you need to tell it to, hey, I want you to tell it, hey, in this function, you're going to return string, and the moment you return string, you need to have this. Maybe you could use a return keyword like this, and then the moment you add that, it will return, or you could just go like that. So let me try to show you a situation where you may try to return a variable that is not the same, and I'll show you maybe how Rust may complain. Maybe I'll try to return maybe we have a variable called x, which is 5 plus 10,
Yes.
and then I return x. So if I return x, it will already complain and it will tell you, are you trying to, let me try to cover that. It's telling you, hey, I expected a string and then I found an integer. So this is why I think people love Rust very much, because it tells you what the problem is. Try to do this in JavaScript and you will tell me if by now you haven't opened ChatGPT. So yeah, but Rust it tells you like, hey, I expected a string, but then I done it. And then when you do that, you can see. Functions can return a lot of stuff. It can return Boolean. Maybe to take you back, if you want to make this work, you over this, and then you see, hey, it's expecting an integer. Maybe I'll have to change that to i32, and you can see it works. So they can also return Booleans. So if I return a Boolean, maybe I say my Boolean is 5 is equal to 10, and then if I write x, you can see here it's returning a Boolean because 5 is not equal to 10, which is false, and it's a Boolean variable. But if I come back and put a string, and I save, it's complaining, but hey, I expected a string, I found it. A good number of stuff it can return. It can return arrays, it can return all of that. So you can go ahead to the documentation and look at functions. it covers a lot of stuff, a lot of stuff, a lot of stuff, a lot of stuff you want to go through and you want to go deeper. Yes, so I'm not going to cover expressions, the if else. I don't think we are going to use them as much in this course, in these lessons. But they are very, very basic. They are very similar to what you guys may understand. So you can look at that. We have a variable, a number, and it's telling you if number is less than 5, the condition is true, else the condition is false. So it is as straightforward as that. So the control flow, and yeah, it is something that you can go to the documentation and look through. It's something that is very, very basic, and I don't think we are going to use that as such. So, but I'll cover it if it comes up. I will show you guys how you can go ahead and use it. But yeah, I'll go ahead and try to cover the most important stuff. That's why Rust is special according to what the Rust teachers say. So another topic that you need to keep tabs on is ownership. So I didn't want to start ownership as the time is moving. I don't know if Diana, it's okay to cover part of it because it's a little bit comprehensive topic.
Ownership.
I don't know if it's okay if you have of it. Yeah.
Okay. I would think it's okay to cover it, but then when you are covering it, probably when you're developing some DApp, you can again give it more clarity. But since we are covering the entire documentation, the initial things now, you can cover part of it, but you can maybe yeah.
Okay, so
also other people can suggest, by the way.
Ownership.
Baker Centum was saying, not today, ownership needs its time. So in the chat, I don't know. What do you think? I think we can go with covering it. We can just cover it broadly today, because I know that these concepts, you repeat them as you're developing maybe something. Yes.
Yeah, true. Okay, so I'm going to try to go through a higher level of how ownership works. Maybe tomorrow I will look through comprehensively. Maybe we'll look at some examples of how it works and all of that. Yes, but what makes Rust suitable and why people love it is the concept of ownership and borrowing. So maybe if you want to go through the documentation, you can look through what ownership does. This is a very, very good documentation on understanding ownership. Yeah, but essentially what ownership is a way that Rust was designed to do memory management. So when you program in a few programming languages like Python, like JavaScript, they come with what they call a garbage collector. So what a garbage collector does, it allows you to, it helps to clear memory and allocate and keep tabs of what is defined in what type of memory. So when you're writing a program, every code, every executable that you make is managed by the computer, and that computer has what they call the memory. So when I declare a variable, for example, like let my name is Bruce, for example. Okay. So this variable is stored somewhere in memory. Okay. And when I try to print this name, using maybe the print macro, like this. If I try to print that, what happens in the background is the compiler will need to know where Bruce has been stored in memory so that I can look for it and I access it somewhere. So when you're using a programming language like Python, like JavaScript, you do not need to know where Bruce has been stored in memory. You get JavaScript and Python will do that for you. And when you are playing around with the variable, when you are changing it, when you are slicing it, when you are updating it and doing all that stuff, you do not need to know where Bruce is. Okay, the garbage collector in Python does it for you, and it just keeps on. When you move Bruce somewhere, it clears where Bruce was and it cleans up for you without you having to think about that. When you're using a language like C++ or C, you need to know where Bruce is. You need to know where exactly Bruce is going to be. And before even you declare Bruce, you need to know what size is Bruce. Okay? So, which is why it made programming a little bit difficult for the people like who really didn't want to think about that. Because it's what they call memory management. Because you are the garbage collector. As the programmer, you need to know where to clear, where to clean, where to access the pointer, and where to do all of that. So, but Rust does it in a very nice way. It blends the two, whereby it doesn't have a garbage collector, but it helps you to play around with the memory management without having to think about where the pointer is, but with also not having to do it for you. So it guides you in a way. It guides you to do it in a safer way, without using the garbage collector, but in an easier way. I don't know if that makes sense. Take an example. When maybe let me give you a higher level overview of the way I think about this memory stuff. For example, if you are in a restaurant, for example, just think about you're in a restaurant, and you want to go to you enter the restaurant. It's a very small restaurant, and when you enter, your table has been reserved. Actually, you call it even before even you check in. You call the restaurant. You tell them, "Hey, I'm coming. My name is Bruce. Reserve me a table." So the moment you get there, you already know where the table is. You just come and sit there. Get. So by the time you enter the restaurant, you already know where your table is. You already know where your reservation is, and you already know where the time that you're going to stay. I mean, the time you're going to arrive and the time you're going to leave. Everything has been set. There's no confusion. It's very easy. Just go, sit, eat, leave. Everything is there. So I think of that as the stack. The stack works in that same way. So when you have a variable, for example, like a number, maybe let's say age. If I have an age of 24, so this age 24 is a fixed number. Like the compiler knows what 24 is. 24 is 24. So when it's getting stored onto the memory, the fact that it knows the size of 24, it's going to be stored on a memory side called the stack. So what the stack does is it stores information that is not going to change in memory. So the moment you declare this, 24 will be stored in stack as 24 with its size known as it said. And the way the stack memory is it gets stored on top of each other. So think of how you could store plates. It may be in a cupboard, maybe on a table. You stack on it as the top one goes on top, the topmost one, then you add another one, then you add another one. So when you want to get to pop off one, you start from the one that entered last. So I think it's called first in, last out. So the top one will go off first until So when you have 24 will be stored on the stack as that plate. You think about the analogy of the plate. So 24 will be that plate, and the other variables that you add will also be stored as plates on that. When you want to access 24, you'll have to pop up all the other places that you added on top of 24 until when you get to 24 down. So that is how the stack does. The stack memory does. So for variables like integers, because we know what the bytes of integers are, we know that this is I32. We know that maybe if I have a float of I64, we know its bytes, we know it upfront. It will always be stored at the stack, and we know how we are going to pull it from the stack just by popping off the top one. But then the issue you may run into is if you have variables that may change. For example, maybe you're building a program that is going to require user input. For example, Twitter, So someone is going to have text. Maybe let's say they have the content variable. Maybe on the content variable, something like that. So we do not know how big content is going to be. It could be they could write Bob, but then they could write Bob Joel. They could write Bob what? They could write a lot of stuff. So we do not know how the size of content is going to be. But then remember, we said that every value that's stored on stack needs to be known upfront. Before it's there, we have to prepare for it. It's like the analogy that I gave you of the restaurant. You call in and you tell them, hey, I'm this, I'm coming at this time, I want this food, and they tell you where the table is. They know it upfront, it is this 24. But then this one is not known. We do not know how long or how small content is going to be. It's going to be dynamic if you think of it that way. So when you take, maybe if I take you back to the hotel analogy, I think of content as this time you're going with friends and you're not going to take any reservations. So you go, you have your friends, maybe you have 3 people that have confirmed that I'm going to come, and then maybe you have 5 others that are not sure, they're like, I may come, I may not come, so you're not sure of what the number is. But one thing you're sure of is you want to go. You want to go to the restaurant, and you're sure you're going to go. Some of your friends are going to find you there. You do not know the exact number, but you have to go. So the fact that you do not know the exact number, you cannot call upfront and reserve, because when you reserve, they may give you a big table or they may give you a small table which may not fit you guys. So the option that you have is to go there and you sort it out there with the people that are there. So it's how it is. So content are the people that are dynamic. The number that it has to be there. So you can't put content on the stack because stack has to be known. The size has to be known. But then the fact that we do not know the size of stack of content, that means we'll have to put it on the heap. So what the heap does is it allows you to store memory that it can be dynamic. I'm sorry, not memory. It allows you to store a value that can be dynamic, value that can change anytime. For example, if this content has been saved as Bob, and maybe the user changes his mind, and maybe they add in another, or they delete, the heap can allow you to store that dynamic. You can declare it without knowing the size of it. But then the issue with the heap is it does not work as how computers work. And the way I think of it is, I think it was brought in a way of allowing to extend the functionalities of computers. Because if you go back and you peel down a layer, and you remember that computers have to work with the stack. The memory has to be worked with the stack. So how does the heap come into place? So when you investigate and see the way the heap works, you understand that the heap is still this memory is still being stored on the stack. The heap is just a layer to allow you to store on the stack. So this dynamic memory here is still being stored on the stack, but in a very nice way. So here, yeah, freeform. So let me try to draw a few shapes to show you guys what I'm trying to talk. Memory here. Maybe let me get here. I have words here. Like we have the slot there, we have the slot there. Okay, we have the slot there. Like that. So this is the stack, and then this is the heap. So, like we said, the values that are known up front, we know 24 is
Mr. Jovan, I think
can just go as 25 here. Of course, it's not going to go as 25, maybe it will go as this funny memory stuff like that. Okay, so maybe that is our 24 on the stack. Maybe you have another variable of 100, maybe it's represented like that as bytes. Maybe we have another one. So this is how it is in the stack. So as you can see, the first one to get added goes down. The second one goes up. The third one goes up. The last one goes on top. Yeah, but if you get the idea. So this is the analogy I was trying to give you about the plates. So if this is our 24 was down. So for you to access 24 down here, you'll have to first pop off this, then you access 24. But the cool thing is that the compiler knows that 24 is this how many layers down. So it will always know how many plates to pop off before it can access 24. So yeah, it knows that this space is this size and 24 will fit here and 25 will fit here, and it's easy. It's very easy. Pop off, and for the heap, if the situation that I gave you for the string is dynamic. The string is going to grow. So it may be as small as this. Maybe my memory is very small, so we try to extend it down here. So maybe I have a string as Bob, and Bob is this size. But then the user adds a few characters and it's as big as that. Clearly you can see it cannot fit. So yeah, forgive me for the visuals, but I'm just trying to show you how I think of this stuff. So clearly you can see that the string as Bob will not fit, and you never know. The user may have it shorter or may have it longer. So as a string, it's very difficult to know because it's a bunch of characters and shells that have stringed on two together to make the word with even spaces. So the way the computers will have to do is it will have to store it on the heap. So for example, if for example this is a string of hello world, let's say hello. Yeah. So maybe the string is hello. So on the heap, what will happen is it will be split into this. For example, it will be split into edge. So edge will come here, E, and then I don't know why it's capitalizing, but yeah, get the idea. So L, and then L, and then O. Okay. So get that. So on the heap, it's split as characters and they align like that. And the good thing with the heap, it's extendable. It can always extend up to down here. So if the guy writes hello world, it can always shrink and it can always reduce just to fit the word. So, but then nothing can be stored on the heap. Everything has to be on the stack as computers are designed. So when you're a programmer and you're doing it in, okay, let's not first go to the programmer. So when it's on the heap as this word, what will happen is the computer will have a pointer. It will get this information and it will analyze it. It will say, okay, what does the string look like on the heap? The string has characters 1, 2, 3, 4, 5. Okay, the characters, it has 5 characters. Beautiful. So it has 5 characters. Okay, how long is it? Like, what's its length? Okay, the length is 0, 1, 2, 3, 4. All right. Okay. So the length is 4. And then, so it creates this small information. I don't know how to put it up.
Right click.
Okay. So it has this small information that represents what is on the heap. Okay, it represents what is on the heap. And then it will create an arrow. I think of it an arrow that will, they call it a pointer, but I think of it as an arrow. So it will create a pointer, and this pointer, along with this information, will reference what is there on the heap. So if I get this,
I think we have a hand. Somebody raised their hand up.
yes.
Jackie, you can talk. I saw your hand up. I don't know whether.
Yes, Jackie.
What's happening, people? People are many here. I think. Oh. You can. I think you can complete.
Okay. So, with the representation of what is on the heap, about the characters here, it will create a pointer that represents what's on the heap, and that information will be added to the stack. For example, it will look something like this. Okay, so it will look something like this, maybe like that, and this is what will be on the stack. So this pointer will always keep track of what is on the heap. So the cool thing here is that you can always extend what is on the heap, and the pointer will always know where the stuff that is on the heap is. So that means we've extended, we can have as long as the string goes, we can have it as short as it is without having to alter what is on the stack with the power of what the heap is. So in traditional programming languages, for example, languages like C++ and C, you had to do all this stuff. Like you had to write this stuff. Like you had to do this pointing stuff. Like you had to do this. You had to know how to do this. You had to know where the heap is, the variable is on the heap. You had to keep track of where it is, and when this changed, maybe when this word had been deleted, you had to come here and clear. You had to clear, because if this goes out then this is referencing to nothing here. You get. So you have to keep track of what is happening on the heap and the stack. When you delete here, you have to come here and keep track and say, hey, this has gone. So yeah, and it is something that wasn't very easy to do. With languages like Python, like JavaScript, you don't have to worry about that. Everything is done for you. The garbage collector knows, it keeps track of what is happening on the heap. It keeps track when you delete what is on the heap, it will kill the pointer, it will update what is on the stack, and yeah, you just keep on coding in a very nice way without worrying about that. But with Rust allows you to do it in a very nice way and in a very simple way, without having to compromise the security and the speed, because the garbage collector makes it a little bit slow when it does it for you, because you lose the power of the memory management and it keeps it, that you lose that power and the flexibility. But Rust keeps you with that, and it allows you to reference this, it allows you to do the heap allocation, it allows you to clear without even thinking about where the location is and the pointer and thinking about all that computer science stuff. So it is something that I was planning to cover in the extensive ownership, because this is where ownership and borrowing and reference comes in, because ownership is how you can do the stuff, it's how you can delete this and keep this out of and change this and keep this reference, maybe play around with this. It is how ownership allows you to do it. So I had to go through the background of why we would have to do stuff like this, because I think in my early days when I was learning Rust, I did not know why we had to do this stuff until when I had to go through at how memory and these pointers and this stuff works, and then I came up to appreciate why Rust did it in the way it does it. So I had to cover it with you guys, if you care. So if you want to go and increase, like you maybe you're curious and you want to extend and see how it works, really recommend you to read this part of the documentation. It's very nice. It's very nice. You don't need to have the computer science stuff, because I know this is a lot of computer science of which I do not know a lot. But yeah, this documentation covers it in a very nice way, and I think if you go through it, you can really appreciate it. I was thinking, because getting you that background, I was thinking that here is where ownership will kick in after all this logic and explanation. Maybe I think it would be nice if we carry on from this tomorrow, Vianney, because I think this is a good point. We can to leave it here, then we can build on top of ownership and reference and borrowing on top of that tomorrow. Yeah.
Yes, I also agree with you. Thank you for at least for the first breakdown. It is something that we can continue with tomorrow. We are going to upload this video. I think it will be there. I'm going to check on the YouTube channel, so you can check the Central Code YouTube, or yes, in the chat. And thank you so much for the breakdown. I know it has been a solid lesson, but that's how Rust is. Yeah.
Yes, unless we have questions, then.
Do you have any questions, Mr. Samuel and everyone else? We have. If you don't have any questions, I think we can call it a time. Thank you so much. It has been really a great.
Thank you guys. Thank you so much. See you tomorrow. Same place, same time. I'm going to share with Vianney the repo. that you've been planning to play around, then you can clone it and try to play around with what you can. Yeah.
All right.